Hi there, and welcome back for another Level Up series video. I am David Pitcher, and I'm going to be talking to you about how to get started with soldering. So, if you've been in Hackspace, you may have been prototyping your electronic device. Here we have a little game device, and it's plugged together with these jumper wires in a breadboard, and it joins those components such as the resistors and buttons that we have here to be able to shine these LEDs. Now, the biggest problem with this is that it can cause some issues, such as the resistors here have long unshielded legs that may join together and cause cross connections and weird artifacts in your electronic design. Or jumper wires may be pulled out or dislodge, and you won't easily be able to figure out how to put it back if you've got a complex circuit. So the next stage would be to get a printed circuit board made or a PCB. Now, PCBs are in a lot of electrical devices. They're not just in computers and smart electronics. Here we have a speaker, and you can see that there's quite a lot of circuitry on there, and it's all added to a PCB to give it that sort of order and structure and to actually condense that electronics into a smaller device. So let's get started. First things first, we need a soldering mat. This is made of silicon, which is highly heat resistant. It protects the work surface from burns and bits and pieces from your soldering iron. So next we need the soldering iron, and this needs to be positioned correctly so you're not reaching across your desk. I'm right-handed, so I've moved it across to the right of my bay, and I've made sure that the wires are all close together and not outstretched or taut. Next we have solder. Solder comes in a number of varieties. It normally has flux within it. Flux helps remove the oxidation and the solder to flow nicely on the metal. Sometimes there is need to add extra flux, so here I have a flux pen. This is mostly used for surface mount components or components that have extra oxidation layers that you want to actually remove to get the solder to flow better. Here is some tip activator. Tip activator is a mixture of things. It does have a very nasty fume, so make sure you use it with extraction. And what it will do is it will clean away the oxide layer. But you shouldn't use it with any soldering iron that has the heating element and sensor in the tip, as it does contain an acid that can actually get into this and destroy your soldering iron tip. Next we have solder wick. Solder wick is a braided copper weave that has impregnated flux that draws up excess solder or solder away from the joint. So now we have to think about extraction. Solder, the flux at least within it, produces a lot of fumes that are nasty and you don't want to be breathing in. There are a number of extraction options such as fans like these or ones that have filters, but we do always want to make sure that it's blowing away from us if we're using one of these cheap fans and that we have good ventilation in the room. In Hackspace we have soldering extractors, and these soldering fume extractors draw the solder fumes away and it passes through carbon filters before recirculating. So next we need to set up our soldering iron. We need to add some water to the soldering sponge, and we also have a brass sponge for cleaning the actual tip. So just by adding normal water, here we've got deionized water, but you can use tap water. We're going to wet the sponge, and it's actually the thermal difference between the temperature of the tip and the sponge that allows it to be cleaned efficiently. So we're now turned on the soldering iron and we're setting it up to the right temperature. Lead-free solder normally melts around 380, so we've set our temperature here. The soldering tip is very dirty, as you can see, and it's important to make sure that we clean the tip so we get proper transfer of heat. The actual oxidation will insulate the iron and you won't get proper conduction, until you clean it and it's nice and shiny. So here we're just putting it on the wet sponge, and you can see that the oxidized layer is just breaking off with the thermal contraction with the water. If there's harder residues to remove, you can use the brass wool. It's very important to, once you've cleaned the tip, to add fresh solder. And what this will do is it will cover the tip with some solder, and it will prevent the oxidation of that tip again and keep it nice and clean. If you do have excess solder, just wipe it off with the brass. So now we're ready to solder. Here I have got a kit, and this is actually the kit which was put out in the breadboard at the beginning. And we're going to solder a couple of these components onto the actual PCB. Now the PCB works by soldering the actual legs of the components onto pads, and you can see on this board it's a single-sided board and there's no pads on this side, and so therefore we need to stick the components through the side with no pads so that the ends of them protrude through this way, and we can solder the ends of the components to the pad. So here I'm pushing a button through the PCB. Now to solder this efficiently, we need to heat both the pad and the actual pin of the component. Now some components you really want to make sure that you don't heat too much. Things with plastic in, capacitors and other things don't want to be heated. So we want to touch the pin and the pad for as little as possible to make sure that we heat it up, but make sure we heat it up to the right temperature and to be able to melt the solder on here. You can see it's moving around a little bit, and we'll come back to that in a second. So here we have a cross-sectional area of the board. You can see there is the hole for the 3-hole component, which the component lead goes through. Surrounding the hole is the pad, and what we want to do is we want to bring the soldering iron right in to this part. We want to touch the pad and the pin so that both heat up to the desired temperature. Now if you do this sufficiently, when you actually apply the solder will flow in a volcano-like structure, and it will stick to the whole pad and produce a proper solder joint. If the pad is not heated sufficiently, the solder will not want to stick to it, and you'll get this beading effect. This will produce a very weak joint that is likely to crack and break and cause issues in the future if there's any stresses on the board or movement of the components. So let's have a little closer look at the soldering. Here you can see that the soldering iron is right on the pin and the pad, and you bring the solder onto the pad, and it should, when the pad gets up to the right temperature, melt the solder and flow over the whole pad. If you're having issues with the solder, getting the solder started, just lightly bring it closer to the soldering iron so that it melts first, and then draw it away from the soldering iron around the rest of the pad to move the solder around the component lead. Now you would have seen that I've had quite a lot of issues with the movement of the board, and what you really want to do is secure it properly to prevent you bumping into other components and potentially burning your own hand. So in this case we use a helping hand, and a helping hand, there's many different varieties. This is the most common. It has articulated joints that allow you to lock them off at different positions to hold your PCB or components or wires at the right level and right angle for you to solder. It also has a magnifying glass to view the components in a bit more detail. In Hackspace we have what we name the Mega Helping Hand, and this has also gooseneck sort of articulated claws and magnifying glass, but it also has a platform that's designed for holding your PCBs in place. Here, once you put them on all four corners, the PCB is quite secure, you can't shake it off, and it's much easier to solder your components on this way. Once you have the board secure, it also speeds up your soldering as you're not worrying about the movement of the board. Soldering wires together is slightly different. Beforehand, when we put the components in the PCB, we've heated both the lead and the pad and brought the solder in together. This is a lot more tricky with wires, and therefore we solder it in a different manner. We bring back the helping hand and strip the wires. Twist the wires just to make sure there's no frayed edges, and add them to the helping hands to hold them for us whilst we apply some solder to the end. Now we're going to do what's called tinning the wires, where we add some solder to the actual end of the wire. You can see I cleaned my soldering iron again because with wires you really want a good clean solder iron because it can be troublesome to do that with a dirty one. Here I've added a little bit of solder, and I haven't left the soldering iron too long to prevent the plastic melting further down the wire. Do this again for the other wire. And once we've done this, we can then melt the solder that's on each of the wires and get it to solidify back together with both wires touching. Now this can be quite tricky and fiddly to get in the right position, but one of the things that you must remember is that if you're going to do this, normally you'll put heat shrink to insulate the joint that you've made. Now my wires are free on each of the other ends, but a lot of people do forget this, and it's annoying because you'll have to desolder them to apply the heat shrink again. You want to slide the heat shrink down the wire as far as it can go, or at least a couple of centimeters, as the heat will transfer from the joint when you're soldering, and it can actually shrink the heat shrink and anchor it into place lower down on the wire. So as long as it's far enough away, the heat will not cause this, and you can actually solder the joints together, solder the wires together, and once you've done this, it is a little bit tricky. You can wait for the solder to solidify, and you should have a nice strong connection. This will then be made stronger and also insulated by the actual sliding up of the heat shrink over the new joint. This can then be shrunk using a heat gun or a rework station, or even a hairdryer possibly will allow you to shrink the heat shrink onto the wire. So as always, subscribe to our channel to get the latest notifications of videos and our Level Up series, and go to our website for news and events of the Hackspace. Until next time, goodbye.